Okay, so this is part two. So now let's plug in the values. It'll be 2 times the value for double bond O is 496. Let's scroll a little up here. And on this side, altogether, once you calculate it, it's going to give us 2644 kilojoules per mole. And on this side, when we plug in the values, this is going to be 805 plus 4 times 463. And so, once we calculate this, it's going to give 3462 kilojoules per mole. So, now we're going to use this formula where delta H is the energy needed to break minus the energy needed to make. So this is the energy needed to break and this is the energy needed to make. So we're just going to plug in those values and it's going to give us 2644 minus 3462, and this gives us the total answer is negative 818 kilojoules per mole. And this is how you solve a question. Now, the reason it became so long is because we understood how to separate it into their bond forms. So let me just show you the mark breakup. So for the marks you'll get for this, you'd get 1 mark for this. Then you're going to get 1 mark for this, 1 mark for this, and 1 mark. Uh, yes. So you're going to get 1 mark altogether for this. This is the mark breakup. And so now I'm going to take one more example just to make sure that we've got this. So I want you to pause the video and try the question on page number 14, or you could do it along with me. Page number 14, I'm going to do part B. So I'm going to draw a line and we're going to do part B. So part B has the equation C2H4 plus H2 gives C2H6. And remember, all of these are in gaseous forms. I keep forgetting to write that, but please don't forget to write this. So let's look at the breakup. So there are 2 carbons, and we know that a carbon will form double bond, and we're going to get 1 hydrogen, another hydrogen. We're not gonna have a hydrogen here. Oops. We're gonna have a hydrogen here and a hydrogen here. To see this breakup again, we are going to have, so as usual, carbon has 4 electrons in its outermost shell. So it's going to be like this. Actually, I keep making this mistake. So we're going to join this carbon here, and this carbon is going to share its 2 electrons. So therefore, carbon has 8 electrons altogether. Oh, it's gonna have. Oops, sorry about this. Yeah. So we're gonna have 1 electron here, 1 electron here. And so the hydrogen has 1 electron in its outermost shell and needs another electron. So it's going to come like this. Then this hydrogen is also going to borrow this side. And this hydrogen is going to borrow this electron. And the other hydrogen is going to borrow this electron. And this is how, because there are 2 electrons being shared here, it'll be double bond. And here, since there is only 1 electron shared, it's going to be a single bond. Now, between hydrogen, it's going to be a single bond because let me write it like this. It's going to be because the hydrogen has 1 electron in its outermost shell, and this hydrogen has 1 electron in its outermost shell. So adding these two up, you've got 2. Next, let's look at C2H6. So what happens here is we've got 2 carbons and we've got 6 hydrogens, so it will form in this way. Let me just bring this down. Yeah, it's going to form here. And this is because C has 1 electron here, 1 electron here, and it has 1 here, 1 here, 1 here, 1 here, 1 here, 1 here. And now the hydrogens are going to come. So we've got 1 electron here, 1 electron here, 1 electron here. And so it's going to form 1 hydrogen, another hydrogen, another hydrogen, 1 here, here, and finally 1 here. So this is how it breaks up. Now since we know how it's going to look, let's put this all together in the equation form. So we're going to have C double bond C, single bond H, single bond H, single bond H. Oh, it's not going to be here. Got a little carried away. Then we've got plus hydrogen. And we've got, gives us the huge molecule. Okay. Oh, okay. So we know how it is. I'm not very good at drawing lines. So now let's plug in the values. So this is our energy to break and our energy to make. So on this side to break, we have 1, 2, 3, 4. So we've got 4 C single bond H. we've got one C double bond C, and we've got an H single bond, H single bond H on this side, and on this side, we've got one, two, three, four, five. We've got six. We've got six C single bond H, and we've got one C single bond C. So plugging in the values, you're going to have 4 C single bond H in the data given is 413, plus for the double bond it's going to be 839, and for the single bond H is 432. On this side it's going to be 413 plus C single bond C is 347. And altogether, when you add them up, they should give um 2923 kilojoules per mole. And on this side, you should get 2825 kilojoules per mole. Putting that into the equation that we know, uh, delta H will give us 2923 minus 2825 altogether gives us 98 kilojoules per mole. And this is going to be minus. And this is how you do bond enthalpy.